In an early video, we used linear regression to study some wine data. In this video, we're going to do the same thing, but instead of using all of the variables in the regression, like we did in the first video, we'll first use PCA to do dimension reduction. And then we'll do the regression using a smaller number of variables, and we'll compare our results. All right, here we are in Databricks. We know it, we love it, maybe. So this first cell in the notebook is just importing the data. And so this is let me run it. It might take a while because we need to start the environment. This is, we're importing the data, we're defining the feature columns, we're creating the assembler, we're doing all the stuff we did when we performed linear regression the first time. And we are breaking our data up into training data and testing data. Here is the linear regression code. I'm not going to dwell on this because this is exactly the code we ran in the previous example. We're not doing anything with PCA here. We're just running some linear regression. There we are. And again, I should emphasize we're using big data tools to learn them. We're not really looking at big data sets. So, because these tools are not optimized for the data sets we're looking at, they're less efficient than if we didn't use them. But again, we're just learning the material on these data sets. Now here, we'll use PCA. So we've got to run the scaler. Linear regression is scale independent in the sense that, changing scale won't make non-linear data linear or vice versa. So we didn't have to do this with the regular linear regression, but we have to do it if we're going to do anything involving PCA. And we've got, how many data sets do we have? How many variables do we have? How many features? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. After messing around with this a little off camera, I've decided to create the first 3 principal components. So I create these, and then I perform linear regression on the principal components rather than the original 11 variables. With this code, and then we've got our diagnostics down here. And I will run this. And here we are. And when we look at our diagnostics, we get very comparable results in terms of the quality of regression. Like the testing R squared when we used all 11 variables was about 0.259 versus 0.231. So again, pretty comparable results, even though we've performed major dimensional reduction, right? We've gone from 11 variables to 3 variables, and we can still perform linear regression at about the same level of quality that we did in our earlier video.